Okay, so following on from yesterday's lesson, which was on measures of central tendency, I thought I would start by doing one of the homework questions. So this is from exercise 11.1, question 2a, find the mean, median, mode of each of the following sets of scores. So this is data set out in a frequency table, very similar to the example that I did in class for you. And you can see I've actually created the frequency table that you need here. So score column, frequency column, FX column, and a CF or cumulative frequency column. So let's use that to work it out. So the mean, which is X bar, equals the sum of FX over the sum of F. Because we're working with frequency table data here, we're not working with individual data. So read the total straight off your table, and that's going to give us a value of 8.85. Okay, so we also need to find the median. Now, remember, this is n plus 1 over 2 score or position. It's not the median value. It tells you where the median is. So there's 40 data items here. So that means we want the 20.5th score. Now, because it's grouped, we actually don't need to go and average anything. We just need to locate where that is. So if we have a look at our cumulative frequency in here, in the row that includes 9, this is the 19th to the 26th scores in this row. Equals row 9. So that means our median is in there and all the values in there are 9, so our median is 9. Our mode is the most occurring, so again it's 9, and we know that because 8 is the highest frequency in any of the rows, so most occurring. If you have any problems at all, please see me in class and ask for extra help. Okay, so what we're actually going to look at today is finding measures of spread. So we've looked at the center of data, but it's not always enough information to give us some. So here are 3 different sets of data. Now, the mean and median of all of the sets are 10, but the 3 data sets are really quite different if we have a look at them. The first set is quite closely grouped, so they start as low as 8 and they only go up to 12, whereas the second set starts as low as 2 and goes up to 18, and there's a relatively even spread across it. But the third set is even more spread out than that second set of data. Yet if we went off a measure of central tendency, such as mean or median, then we'd end up with the same score, 10. So sometimes we can use what's called measures of spread or dispersion to explore further. In reality, we probably would use measures of central tendency and measures of spread together to give us a broader picture of the data. So let's have a look at those things that we're going to work with for this. So we've got something called quartiles. Quartiles relates to quarter, which means we divide our data into quarters. So if you think of the first quartile as being the median of the lower half, remember median's the middle, so that could be the median of the lower half, and the third quartile being the median of the upper half of the data if you split the two, and the median itself is actually the second quartile. So you'd have a first quartile, second quartile, third quartile. The fourth quartile would actually be at the end after the data is finished. So we don't use that one. But first and third commonly use, median we commonly use, but we call it the median. Okay, so there's 2 formulas you have to learn here. You won't get given them, you need to know them. So if n is odd, so that means if we have an odd number of data items, then the first quartile position, Q1, is found by using this formula, n plus 1 over 4. If our number of data items n is even, so for 12 data items, for example, then Q1 position is found by using n plus 2 over 4. So the first thing you need to do is order your data. Second thing you need to do is figure out how many you've got and which formula you're going to use. Okay, to find the third quartile, luckily we don't need more formulas and we don't need to remember those. We're just going to use the Q1 position that we found, but we're going to count backwards in from the end of the data. So we're going exactly the same as we did before, but we're counting in from the highest score instead of starting at the lowest score like you would do with Q1. The range, so range you would have heard before. Range is another measure of spread. So this is the largest distance between the smallest and largest data point. In other words, largest score minus smallest score. That will tell us how range over what area our data is spread. Then we've got something called the interquartile range, which you may not have heard before either. So it's the distance between the third and the first quartile, which you found up there. So you would use these to work out what's called the interquartile range, or the IQR. And that's just Q3 minus Q1. So you can see all these things tie together. Now, the third type of measure of spread is something called a standard deviation. So it measures how far every data item is from the mean. It's abbreviated to SD. It's got this little symbol that you can see here, and it's calculated using these two different formulas, and I'll show you how to do each one of those. So with standard deviation, so we've got data set out in a bell curve. You would have all seen some sort of bell curve before. So what that indicates is a lot of our data is in the middle, and as we get further and further away from the mean, there's less and less. So the mean occurs in the center, and standard deviations, or this SD that we're working out here, tells us how far the data item we have is away from the mean. So let's say this is 50. Above it, in the right-hand side, you would have one standard deviation away from the mean. So that might be, I don't know, 75. Then you would have 2 standard deviations away from the mean. 3 standard deviations is usually as far as it goes. This might be 88. This might be 95. So in a similar way, you can actually go to the negative side of the mean. So this would be minus 1 standard deviation away from the mean, minus 2 standard deviations away from the mean, minus 3 standard deviations of the mean, away from the mean. So each one of these are the same. So they're the same all the way along. And they are calculated by using this information here. So in a similar way, if this was 25 away from the mean, this might be down to 25 here, and then there was, 13 different, so this might be down to 12 here, and this might be down to 5 here. So if these were scores out of 100, this could be what it means, how it's set out, how far away from the mean it is. So if you have a basic understanding of that, that's all you really need for now. It just shows you how far a particular score might be away from the average for that group of scores. All right, so let's have a go at finding some of these things. So for the following scores, now we're working with individual data here, we're going to find the range, the standard deviation, and the interquartile range. So again, the very first thing I'm going to do is put them in order, because it's going to be easier to find. Well, we need them in order for the interquartile range, just like we did for the median, because the median is actually one of the values you can find from that. And it's definitely going to help us with the range as well. So the range equals the highest score minus the lowest score. So in this case, our highest score is 19 and our lowest score is 3, so our range is 16. The interquartile range is found by having Q3 minus Q1. So what we have to do now is go away and actually find Q3 and Q1. Okay, so remember there were 2 formulas to do this. So there's 13 scores in our data. So that means we've got an odd number of data. So we can use the n plus 1 over 4 formula to tell us where Q1 is. Okay, so let's do that. So Q1 is 13 plus 1 over 4, 3.5th score from the beginning is where Q1 is located. So that means it is in here. Q1 is in there. So let's go and find that. So Q1 equals the average of the third and the fourth score, which means we have to add those two scores together and divide them by 2, and it's going to be 6.5. Now Q3 is the same, but it's in from the end. So 1, 2, 3, third and fourth score in from the end is where we're going to find Q3. So Q3 is the average of the 10th and 11th scores. And remember, that's the third and the fourth from the end. They're both 12 in this case, but it's good to show you working that you understand where that's come from, so it's still going to be 12. So now we've got enough information to work out our interquartile range. It's going to be 12 minus 6.5, which equals 5.5. So that's A and B. C requires us to find the standard deviation. So I'm going to write the formula first. It's the sum of x squared over n minus x bar squared. Okay, so there's a few things we need here. We need x bar. X bar is the mean, remember? So we need to find what that is. So remember, to find that, it's the sum of x over n, which if we added up all our data items, we're going to get 127. So you have done this before. In fact, you've probably got this information because it's likely you would find both measures of central tendency and measures of spread. Now what I'm saying here is use the complete number. In other words, don't round at this point because you're going to get a more rounded final answer if you do. So you can just leave that on your calculator and then use that. We also need to find the sum of x squared. So what that means is the sum of the square of each score. And what that looks like is, for example, 3 squared plus 3 squared plus 6 squared plus all the way up to 19 squared. So each score is going to be squared and then added together, which is going to give us a value, 1507. The other value we need for our standard deviation is n, which we know is 13. So now we've got everything. Oh, that was a terrible symbol. Now we've got everything to do that. So let's go ahead and do it. So sum of x squared is 1507. There's 13 data items, and we're going to take away the square of mean. So 9.7692, but remember, keep all those places and then square that. That is going to give us an answer, and this is what you're going to round, your final answer. So that's going to be approximately 4.53 is our standard deviation. So each standard deviation is going to be worth that. Okay, so I'm going to finish this here, and then I'll do another example on the next recording.